Another significant aspect of cortical areas is the different degrees of connectivity between different areas. In this diagram, each small square indicates the degree of connectivity from one area to another area. The different areas run from top to bottom down the side, and the same areas from left to right across the top. So a square in the top right half of the diagram, like the one circled in purple, indicates the degree of connectivity from the cortical area corresponding with that location on the vertical scale to the cortical area corresponding with that location on the horizontal scale. So one small square indicates connectivity from one area to another. Now in principle, the grey squares along the diagonal therefore correspond with connectivity from one area to itself. And in fact, there's much more connectivity within an area than between the area and any other area. But the point of this diagram is to show the connectivity between different areas. Strong connectivity is indicated by dark red, moderate connectivity by pink, and weak connectivity by pale pink. And if the square is empty, if it's white, then there's no evidence of connectivity between the two areas. So you can see that one area tends to be connected strongly to a relatively small number of areas, and more weakly to a few more, as in the example circled in green. Connectivity indicated in the top right half of the diagram is in the opposite direction to that in the bottom left half. So squares placed symmetrically across the diagonal indicate reciprocal connectivity. So you can see that quite often, if there is strong connectivity one way, it's also strong in the opposite direction, like this example, or this one, or this. So there are three conclusions we can reach. Connectivity is much stronger within an area than between areas. Secondly, one area tends to be connected with a relatively small group of other areas. And thirdly, quite often, connectivity is reciprocal. Now, when we're comparing two areas, the area that's connected to sensory inputs via fewer intervening areas is called the lower area. And the area that's connected to sensory inputs via more intervening areas is called the higher area. But often a higher and a lower area are interconnected both ways. And in this situation, there's a strong pattern to the connectivity at a more detailed neuron level. Within one area, pyramidal neurons tend to receive inputs from lower cortical areas on their basal dendrites, and inputs from higher cortical areas arrive on their apical dendrites. So within that area, inputs derived more directly from the senses arrive on the basal dendrites, but if outputs from the area go to a higher area, the reciprocal connectivity back from that area arrives on the apical dendrites.